Please note that this is a sponsored event, and any opinions expressed are those of the presenters and do not necessarily reflect the views of ASCE. ASCE also asks that presenters and participants refrain from discussions surrounding competitors and pricings of products and services. And now, without further delay, welcome to Connections, Services, and Pressure Testing. This is the third webinar in the 2024 series of 4 provided by the Alliance for PE Pipe, WL Plastics, and Core & Main. Each of the webinars in the 2024 series are 75 minutes. We are all excited to get an extra 15 minutes with this fantastic team. And now it is my pleasure to welcome back for the 4th year providing valuable HDPE sponsored webinars with ASCE, Peter Dyke, Executive Director of the Alliance for PE Pipe. Welcome back, Peter.
Hey, thanks, Robin. Another great job by you. And honestly, we are honored to be with you and partner with you on this program and kind of anchor your webinar series, your webinar program. And as you said, this is our third in a series of 4. We have one additional one coming up next month. And today we're going to talk about service connections. We get a lot of questions on polyethylene and how do I connect to the main and how do we connect to other materials. So my resident engineer, Alan Ambler, and the guys at Core & Main have put together a pretty thorough deck, and you have graciously given us 75 minutes to get through this content. But I warn our guests today that this is, it's detailed, it's thorough, and we encourage you to, not only pay attention, but recognize that no longer are these, Robin, survey classes. We intend to provide your engineers a lot of detail so that they can go forward and put together very good drawing sets and specs for the polyethylene jobs. So with that, I'd like to bring on Rusty Reeves from Core & Main. Rusty is one of our 2 sponsors today. We also have WL Plastics, and Rusty represents a fantastic distributor of HDPE products. Welcome, Rusty.
Hey, thanks, Peter. Appreciate it. Core & Main really does enjoy being involved in these. We want to educate as many people as we can about HDPE and what a great material it is, really, for water, sewer, just anything out there. Keeping the good stuff in, the bad stuff out of your pipeline and your water. We have over 400 branches nationwide. We've got 30 branches nationwide that are just fusible. We've got probably over 600 actually, fusion machines and electrofusion equipment to kind of service anything that you need, cover whatever you happen to need. Today, we've actually got helping us out 2 of our regional sales managers, Mr. Dave Mosier, and he is from our North region, and Steve Riedemeyer from our Central region. We're going to be helping out. They've done quite a bit with the water service and connections, different and varied services for different cities. So they'll be joining us and helping out today. And again, thanks for joining us.
Yeah, well, thank you, Rusty. And we'll see Steve and Dave in a few minutes. Richard Colassa, WL Plastics, a pipe manufacturer. Please come on and say hello.
Oh, hello, everybody. Again, thank you very much, ASCE, Core & Main, and you, Peter, as well, for these events. We think they're invaluable. I'm a pipe manufacturer, one of the largest in North America. If you have any issues or concerns or questions about pipe, we're always here and available for you. So like the rest of the team, Rusty is a huge customer of ours. And we work together to make sure that you guys are satisfied, especially in design and planning, if need be. But thank you very much for being here. It's great being back, and hope you think this presentation is very valuable.
Yeah, thank you, Richard. I also want to mention that we have a bench. Robin kind of laughs when we call it that, but it's our bench of experts. We have several experts. Dan Landy, could you come on, or Alan Ambler, why don't you do it? Could you tell us, Alan, how the bench works and what kind of experts we have on today's bench?
Well, absolutely, Pete. So glad to be here. The bench essentially is a group of us experts for HDPE that are there to answer your questions live. So when you pull up that Q&A function here on the webinar, we've got several of us, here's the bench, typing live answers to those questions. So definitely don't hesitate to continue to ask all those questions. And we love to see it. We've got some great people there to help answer those questions as you throw them out.
Yeah, and I'd just like to remind everybody, please don't use the chat for questions, because then we can't track the people that we help and we can't follow up with more information. So please use Q&A. Thank you very much, Alan Ambler. We're going to see Alan a little bit later. We're going to do a live demonstration of service connections on the main right here in our studio. So Steve Breedemeyer and Dave Mosier, could you guys come on and introduce yourselves, please? Hello, Dave.
Hi, I'm Dave Mosier with Core and Main. As Rusty said, I work in our north region, which is Colorado, Wyoming, the Dakotas, all the way across the upper tier of Michigan. So we work in a wide variety of environments, every municipal being a very growing environment for us, but also in a lot of industrial and landfill type environments. We do run into a lot of needs for unique connections, and I'm excited about today's presentation.
Yeah, well, thanks for helping us put it together. Steve.
Yeah, Steve.
All right, we lost you, Steve. There we go.
Sorry about that. Steve Breedemeyer, Core and Main, have the same position as Dave, but in our central region, which is Kansas, Missouri, Illinois, Indiana, and Ohio, roughly 50 waterworks branches in those states work with our waterworks branches and our fusible HDPE branches to bring better solutions to the industry.
Steve, so I know that you and Dave spend a lot of time on the sales side of things, Steve, but tell us a little bit about what you and Dave do to help deliver projects. So like work in the field, what do you do specifically to help guys, contractors in the field?
Well, a lot of times we give them advice on, means and methods on how to install polyethylene, because it is a little different than bell and spigot pipe. And so we go out in the field and meet with customers and talk to them. The classic example is when they're used to bell and spigot pipe, they automatically want to string the pipe. But we'll go out there and say, hey, wait a minute, you're doing polyethylene, you got to fuse it together. Let's keep the fusion machine stationary and drag the pipe to the ditch that it's going to go into. So just little things like that, just lend advice to the contractor community and the municipalities in our various regions.
You also give guys a lot of training, as Rusty mentioned. I mean, this isn't like a bell and spigot system. We do require a little training. Tell us about some training options that Core and Main provides.
Well, Core and Main has a variety of, you said, training options. We do have learning centers in some of our branches where people can come in and be trained on using the actual fusion equipment. We also do a lot of brown bag seminars and breakfast seminars with engineering firms as well. We're very anxious to get involved early on in the project, pre-bid and then pre-construction, so that when everybody arrives on the job site, we're productive. We have high level of productivity.
Yeah, fantastic. Rusty.
Yeah, I was just going to mention, Dave talked about the training, but we can do certification on that fusion equipment to make sure that's becoming more and more critical, that you have the proper people being trained, certified, and know that they are putting that pipe together properly. And so yeah, the certification is very key for connecting the pipe. So whether it's with the McElroy type fusion machines or the electrofusion. So.
Yeah, Rusty, you're so right. One of the things that really distinguishes us from Legacy Materials is, they teach the guys how to put it together in the trench. We're doing a mix of classroom as well as live field work to teach people how to do fusion. So there's a little bit of a higher barrier to entry to get into this game, because there's a little bit more intellectual side to understanding fusion and making sure you're doing it correctly. And Rusty, can you just talk a little bit about what you and I have learned from utilities that have adopted polyethylene without doing the training? What have you and I learned?
I think a perfect example of that happened out in San Francisco. I mean, they did not really stay on top of their contractors that were coming in and doing that, and ended up you can get some cold fusions and some poor installations. So it is very key. And I think the best example of that is looking at the gas industry.
Right.
The gas industry has been using medium density and high density polyethylene for probably the last 30, 40 years. And with that, they have their contractors certified every year. They've got to have a card showing that they've been trained and ready to go. They do have a little bit higher standard. Of course, with gas, you'd better. But I think following with that should be the water industry as well.
Yeah, we push that, don't we? Well, thank you, Rusty and Dave and Steve. Look forward to hearing from you guys shortly. Alan Ambler, I believe it's your turn, and I'll go off here. And I want to say thank you to everyone for tuning in today. Hopefully, you will agree that your time is well spent today. Mr. Alan Ambler.
Hey, Pete, thank you for turning it over. So here on the screen, it will be showing a list of today's topics. Of course, we can't talk about connections or services without talking about the main lines for a bit. So we'll try to breeze through those as quickly as we can. Then we'll talk about all the myriad of different ways that you can actually make connections to that HDPE mainline. Service connection methods. We have a live demonstration through the studio here as well that we will share and show all sorts of different fittings and things as you would connect those out in the real world. And then we'll talk about pressure testing and some of the intricacies there. So here's a good example of traditional open cut use for main lines. Now, the AWWA M55 manual does allow for a design window for safe installation. And now what we're seeing here in this video happens to be a soft bedding that's provided for that pipe as it goes through. Then the efficiency of having a long fused system allows it for this construction crew to be able to install it more productively with less people in the excavation. So while some may think that this is not a safe way to install the pipe, it really is. There's a bedding. They'll come back through and backfill and compact that material with natural compaction. Natural native backfill in this particular scenario as we go through. Here, another way to install horizontal directional drill or HDPE with horizontal directional drill is quite oftentimes the municipalities' first introduction to HDPE, if they haven't used it before. They are continuing to push the boundaries quite a bit for HDD. We're seeing very long runs of very large pipe that are going in to be installed via horizontal directional drill. So some of the things that we're looking for about HDPE is not exceeding the tensile yield force of that HDPE when we are installing it. So we want to know about the friction forces and all those that are happening during that horizontal directional drill process. Earlier this year, we did do quite extensive discussion on horizontal directional drill and trenchless technologies in general. So definitely look at some of the Alliance's previous webinars in order to be able to beef up on that information itself. Another way that HDPE is often installed is through pipe bursting. Pipe bursting is a trenchless technology, and three things are happening at the same time for pipe bursting, and we're fracturing that existing pipeline. We're pushing a temporary soil cavity through with an expander head, so creating space for that HDPE pipeline to come in and follow its suit. So this is a trenchless technology rehabilitation method, and we will come through and replace that existing pipe through this pipe bursting process. The types of pipes that can be made to burst are going to be vitrified clay pipe, cast iron pipe, asbestos cement pipe. The plastic, like a PVC pipe, will be cut through with a cutting head through it, but you will not be able to burst like a pre-stressed concrete cylinder pipe or a heavily reinforced pipe with pipe bursting. Then that brings me to slip lining. If you can't burst that pipe, then you can look at just being able to push in a new pipe to replace that pipe. And you'll have to access that pipe, be able to make sure that your annular space is clean. There's nothing that stops and protrudes that from being able to pull that through. Richard Colossa, you want to come on and tell us about the video that we're seeing on the right here? I think you took that video down in South Florida, and how quickly did they pull in this HDPE pipe, Richard?
Yeah, that was yeah, hi. That was in Miami, just north of the airport. This was a sewer rehabilitation where they were leaching fairly excessive sewer into their ground. But it was about 200 or 350 feet of pipe. They've been doing sections like that, 350 to 800. Ask the engineer. You can see the hole at the end has a strap on it. They usually just pull and segment that pipe in, so it takes a little bit longer. But since that initial hose pipe was very clean and didn't have any protrusions in it, I just said, just push it in. And they pushed it in about 4 or 5 minutes. So it was 350 feet down in about 3 or 4 minutes. It was really good.
That long longitudinal run that we're looking at and allows us to fuse a lot of pipe material in advance. We're getting a fairly good hydraulic improvement just from the smoothness of the HDPE pipe as we're coming through and putting that in. So in some cases, you don't necessarily need to go bigger if we're smoother on the interior of the wall as it goes through. So this next technology is a really cool technology that is unique to high density polyethylene, because we're taking a larger pipe, larger OD, and we're forcing it through a die or a series of rollers. And then we're making it temporarily smaller, as you can see here, pulling it through that existing pipe and then allowing it to retain or regain its original shape. That relaxation period that we're looking at occurs in the first 24 hours as that pipe is allowed to relax and settle. Most of the relaxation will be in that 2-hour time period, but before you make any connections, we want you to let it be for a good solid 24 hours as we go through. So some things that are unique to gravity sewer main lines, a lot of times they'll use DR17 to install this. Of course, they're not pressurized force mains that convey material from a pump station to another location then are pressurized, and HDPE is definitely a good product for these types of scenarios, as to which we're looking at trying to resist that hydrogen sulfide that is often released when we agitate that raw sewage as we come through. So here's a project we just wanted to talk about fairly quickly, where HDPE came in and saved the day quite a bit. So there was pipe failure in the intercoastal waterway in Fort Lauderdale. And then since that was the single pipe that was crossing that intercoastal waterway, they had no other avenue to be able to get the raw sewage across that waterway. So they were using pump trucks, 2,000-gallon capacity pump trucks, vacuum trucks, to take it from one side of the intercoastal to the other. This project itself used a design build process in order to be able to expedite contractors to come through and use a myriad of trenchless technology methods to install new pipe and rehabilitate existing pipe in some scenarios. So HDPE was very good for this process, and it was definitely a rugged and durable pipe for what we're looking at. So inflow and infiltration oftentimes plagues that gravity sewer, and this happens to be an opening within the gravity sewer system, either through broken joints or direct connection between the rainfall event and the gravity sewer, and it'll lead to capacity reductions, and that inflow and infiltration will take over valuable hydraulic capacity within the pipe itself. These SSOs, sanitary sewer overflows, lead to consent decrees in many instances, which is a judicial order that you've got to go through. That municipality has to go through and actually try to fix their system up in that scenario. So there are ways that we can look at our pump stations in combination with rainfall events to see if we have a closed system or if we are getting some of that inflow and infiltration. And I use this graphic just briefly. There's lots of data that you have in running a municipality, lots of information that you have, and this is an easy overlay of that rainfall event in comparison to whether or not your gravity sewer system is closed or it's suffering from inflow and infiltration in that manner. So it is important when we are rehabilitating any pipeline to maintain that service. So here's a temporary bypass as we go through, going from one manhole upstream to one manhole downstream from the run that we are rehabilitating, and allowing us to be able to move that wastewater through as well. So sometimes they simply put door hangers and have an outage period when they're performing the pipe bursting work, and it allows for you to be able to just bypass that one. Yes, Pete.
So we just had a great question, Alan, about whether or not you can pipe burst HDPE. You know, polyethylene is not fracturable, yet the city of Houston does a lot of it. Could you tell us whether or not we can pipe burst HDPE and what we need to look out for?
Yeah, absolutely. So you can pipe burst HDPE through a static pipe bursting process and a cutting head that comes through and simply cuts that HDPE, and then the expander head will push that apart as well. That's static pipe bursting. That's just a different type of pipe bursting, and how it applies the force necessary for the pipe bursting process. There's a hydraulic power pack, and that pushes power across, or the force, the brute force, across a series of rods or cable to that expander head as it advances and pulls through. Pneumatic pipe bursting only uses HDPE as a replacement pipe method because it uses an impact hammer driven by compressed air and inches along with the existing pipe. It is aligned with the existing pipe through a constant tension winch that pulls that expander head through. Great questions. That's what we love. We love all those great questions coming through in the Q&A, and we can answer as many of your questions as we possibly can through this process. So here's some examples of creative uses for temporary bypass as we go through. They're using existing stormwater pipe to be able to pull that temporarily through this. And as that goes through topography, you are going to look at air release valves like what you'd see on the left, to make sure we don't have any entrapped air that is stopping our hydraulic capacity through that. Here's a very good example that I like to use of temporary bypass for the city of Baltimore. They were rehabbing the 78-inch combined sewer. So that has stormwater event and gravity sewer in it quite a bit. So a lot of capacity through this pipeline, this 78-inch that they had, pre-stressed concrete cylinder pipe, and it was rehabilitated using cured in place pipeline and carbon fiber reinforced pipe. Now, in order to be able to make the temporary bypass work for a pipe of that size, you needed 45,000 linear feet of 24-inch, and then lots of fusion machines, 16 bypass pumping units, in a lot of different parts and pieces to be able to get all of that to work. So HDPE is very often used for the very difficult stuff, and then we're going to encourage you to use it for the easy stuff too. So with manholes, what we're seeing now, there's lots of different ways to connect to that HDPE manhole. If you do have an HDPE manhole, they'll have a stub out on the bottom section of it for where you're going to either electrofuse coupler, or you're going to butt fuse right to that stub out for manholes that are not high density polyethylene, and we're connecting to it. If you're pipe bursting, you'd allow the pipe to relax before making that final connection. And then you would put some type of grout around that existing concrete or brook manhole to be able to make that connection. But very often we do see HDPE manholes in very corrosive soil environments because it is corrosion resistant in that manner. So that manhole is necessary for cleaning and inspecting all the main lines as we come through. It gives us a chance to be able to clean, jet any buildup or other debris within the pipeline, and then also inspect that pipeline right when we get there afterwards. So here's just a couple of more examples of an HDPE manhole. So much like your precast concrete manhole, if you're putting a new one in, we want to know what the invert elevations are and directions, and you would tell your fabrication facility that information, and they'd fabricate this fitting for you in their yard itself. So Rusty and his crew have the capability to be able to do that for you as they come through. So here's some examples of those installed manholes. The one on the left for us is in Beaufort Jasper in South Carolina for us. So they went with all HDPE manholes in order to be able to resist their soil with extreme corrosivity. So some of the things that the HDPE will help really with is getting rid of that hydrogen sulfide, or rather being resistant to it. And what you'll see here right in the middle is that concrete being eaten away directly by hydrogen sulfide as we come through. All right. Talking a little bit more here about air release valves. We did before as well. That air release valve happens to be a high point along the line where that gas is going to accumulate. And when we use an air release valve to be able to let that out, then we're able to make sure that hydraulic capacity is not limited. Sorry, the Beaufort Jaspers in Georgia, not South Carolina. Thank you very much, Pete, for making me up to date here. So connection to the main lines, we're looking at laterals as well, and you can pipe burst some of those laterals, which you'll see here in the middle happens to be a small lateral bursting machine. If you've ever seen the Alliance at a trade show, sometimes we do bring pipe bursting to the trade show floor, and we use a lateral bursting rig like this would be. And just the same way that you burst those main lines, we can burst that lateral and bring back that high density polyethylene that we really like to see in that manner as well. So here's some examples of valves. Steve, do you want to come on and talk to us a little bit about how we connect that main line to a valve through something like an MJ adapter from what we're seeing?
Yeah, so this is just a typical valve cluster, and using the MJ adapter, you can see in that picture to the left, we're connecting to a reducer, a mechanical joint ductile iron reducer. On the left, we're connecting to a valve on the lateral of the T, and then back to another ductile iron reducing T that goes to probably a hydrant valve or something like that. Last but not least, at the bottom, that bottom picture is a electrofusion saddle that's connected to the mainline HDPE, and then it's with an electrofusion coupling. The MJ adapter is put on to transition to the gate valve there, and you can see in the video that's just a standard mechanical joint, legacy mechanical joint MJ valve that all water systems have in their system. Just showing you how we connect, and basically it works like a similar to those of you know what like a hydrant T or a swivel T is in the ductile iron business. This is just a polyethylene version of that. So literally those bolts would have to all break for that joint to ever come apart. So it's really the Cadillac or Mercedes of connecting to other piping systems.
So Steve, do you sell these mechanical joint adapter as kits or individual pieces? How is that process? How does that take place?
We sell them as kits, but there's so many different options. You know, like I think this example shows the blue bolts, those which are more and more common. Those are becoming kind of the leading spec. Bolts used to be just Corten steel. We still sell some of those. These bolts are a little longer than your typical T-head bolts for a standard MJ fitting. So yeah, we mate those with the gland, so we get them the right length and the right material. Some specs ask for stainless steel. Personally, I like the blue bolts. I think they're the best for the for this particular option. But yeah, we sell those as kits.
Awesome. So that in the image in the upper right, the most popular video we have on YouTube is that 2-minute video that shows how to install an MJ. You know, one thing I've learned, Steve, is up in Canada, still the Megalug is the standard, what everybody uses. But we're starting to see more and more MJs making it up to these, recalcitrant parts of the United States and Canada. But megalugs work too, don't they?
They do. And the only thing I have against a megalug, I guess, is that it opens it up to installation error, right? So is the individual that's tightening those bolts, is he doing it properly? Is there anybody watching to make sure he's doing it properly? In this case, with the MJ adapter, I think the big advantage is that, man, if that doesn't leak, then they installed it right, right?
Yeah,
so
for sure.
kind of at leak test. But with a megalug, you have to have a stainless steel stiffener inside it to resist those forces of the lugs as they're being tightened. And so there's just quite a few variables there. If it's done right, it's a great joint for sure.
So unique to both of those, the MJ adapter brings all of the force longitudinally through that fitting in its robust nature. The megalug then has force on the outside of the pipe laterally, so that way it squeezes on that stainless steel insert, and that's unique to each of the fittings. But they certainly both will work, and they have for quite some time. So what are we looking at here, Steve?
We're looking at I think this brand is AVK gate valve. So this is a standard AWWA C509 gate valve with a different end. So, gate valves, they're the ones with the rubber wedge. They're the standard in the industry that every town in America uses. The most common one for a buried valve is an MJ valve, which are the ones we saw before. But AVK came up with this very unique connection specifically for HDPE. And so they made the bottom of that valve, instead of a female end that is shaped like a mechanical joint with the bolt holes, they made it with a male end, and that's a barb fitting. And I love this video because it shows you how flexible and durable HDPE pipe is. So just with a whole lot of force, they're literally pushing the pipe over that barbed fitting. And then, as you can see in the lower, or the right-hand picture in the lower corner, there's a stainless steel ring, retainer ring, that's then shoved over the top of the polyethylene pipe to lock it onto the valve. So that valve, and then it's wrapped in, I forget the name of that wrap, but so it doesn't corrode. So you have you've eliminated the bolts, and you've fused this valve into your system. So you've gotten rid of all the corrosion points because that valve is epoxy coated, and in this case, the stem is stainless steel.
So the fittings portion of the HDPE industry has developed a lot of these types of products to really just make it so much easier for everybody out in the field to be able to come through and use that high density polyethylene as we come through. Yes, Pete.
Alan, I've got a great question that just came through. When we compare our material to, say, PVC, cracks will propagate in PVC. And looking at this video of the AVK valve, where they're hydraulically driving that stub end onto the nipple of that valve, it calls the question, well, does a crack propagate in HDPE?
So cracks have previously propagated in HDPE, and the resin has advanced fairly significantly in order to stop that rapid crack propagation. Richard, do you want to come and tell us a little bit about some of those advancements and how long the industry has been working on making them?
Yeah, the test methodology that's used for establishing resistance to elongation cracks or cracking is called rapid crack propagation. The pipe is put under pressure under various conditions. It can be hot or cold, and then you impact it under pressure to see if that crack propagates. And in the gas industry, we have some standards and some minimums there that we follow. So we just use it for water as well. So the advancements that have come from the polyethylene in 3608s, where your slow crack growth properties were a little bit less than the 4710s, that is one of the key contributing factors to advancing resistance to rapid crack, because the way that polymer is put together, I use the analogy 100 times already, but it's a kid's ball pit with 3408, where you can slide through that ball pit. and a crack generation would propagate through that, and it would resist over time, but it does do a sine wave type thing. But in 4710 materials now, all those balls are Velcroed together. So that's the real key. We don't see a lot of crack propagation or rapid crack in polyethylene very often anymore with 4710s.
It's also important to note that the two pipe materials have very, very different temperatures as to which they're brittle, and that ruggedness and durability of HDPE to work with it in the field is one of those real saving graces for us. So I'm going to keep going. Fire hydrants provide a lot of different use within the system itself. We can use it to flush out poor water quality, either through a reactive flushing program or a unidirectional flushing program, in which case we're going to look to directionalize those impurities or whatever is contaminating water supply, as far as not a old water, iron, or other things like that that get in there. So we can use it also for pressure monitoring or temporary water for construction. And here's just a few examples of those as well. That ABK valve also has a stub out for a fire hydrant that we'll be looking at as well. So lots of good uses besides just firefighting. You can control and learn about your operation of your system in that way. So tapping the main is what we're here for, really to talk quite a bit about the service connections when we get to it. Here's some examples of tapping a main that is not live. There's a big difference between hot tapping, which is there's water flow within that potable water main as we get through there. And we'll show you later on some examples of fittings that can be used to do that tap. So here they're making a larger fitting onto the side of the pipe and then prepping this service connection, larger diameter, that goes into a larger building in Minnesota for it. And then others for gravity sewers as well. So here we're looking at small to medium-sized services, metered usage. So there'll be corporation valve that allows you to shut off that lateral or service connection as we come through. It is there sometimes to prevent that cross-contamination we can use through that line as well, and compression fittings can be used for those smaller service lines as we come. So here's some examples of corporation valves. So unique to HDPE, you can't put the threaded connection in directly to the HDPE. It has to be done through a fitting, and we've got plenty of fittings that'll accomplish this for you. The taper pattern on some of these different corporation valves vary fairly significantly. So there are multiple different types of fittings with a different taper on the end of that ball valve that you want to make sure that you're getting for the right use in your system. It varies across the country from place to place and other things. So here are small diameter valves that are made of high density polyethylene with some polypropylene elements inside of them. But you're going to see that these are all corrosion resistant, leak free. In some instances, we can just simply butt fuse that right to the service connection as we come as well. So we like to be polyethylene from point A to point B. It's a monolithic, fully restrained system, but we do recognize sometimes brass fittings are necessary, and that's what you're more familiar with. Here's some trenchless service connection installations. What you're seeing on the left happens to be a existing copper service, and they simply attached on the high density polyethylene on the other side, and are using brute force to pull it out. What you're seeing on the right is a pneumatic insertion tool as to which they'll line up to cross that road for a long side service connection in this scenario as well. So that is a trenchless installation tool. It is not intelligent tool, so you can't directionalize it, but if you get it in the right direction, you can have that set up in there. So Steve, you want to come on and tell us a little bit more about what we're looking for service connections, and share some of your history and the things that you've done in the field?
Yeah, so what you're seeing here is a quite a few different options of service saddles. The one you see there, kind of in the middle with the cork stop threaded into it and the brass threads, that's an electrofusion saddle that's just electrofused to the outside of the pipe. And then the threads are AWWA threads, so they mate with that cork stop, and that's very similar to every other service saddle that exists on any other kind of product, water main. So sometimes today in ductile iron communities, they still tap directly into the wall of the ductile iron, but many municipalities have gone to mechanical service saddles, which we'll show in a minute. But kind of the evolution from that one with the brass cork stop in it is the one just below it, which is also an electrofusion tap saddle, but it has built into it the cutter, so you don't need a tap machine. Basically, that is a and that's why they call it a tap saddle. It's a built-in tapping machine, and it's built into the saddle. And there are literally millions of those in the ground in the industry, in gas systems. So we just took a product that's been put in the ground since the 1980s in gas systems and copied it. Our manufacturers just do the same fitting, but do it in black HDPE for waterworks applications. There's again there's a cork stop into a electrofusion saddle. In this case, you would have to, if that was a live tap, you would have to hook your tap machine like you do traditionally with PVC and ductile to the back of that cork stop. You would open up that valve. The cutter head would go through the corporation stop, cut the hole in the main, and then you would back your tapping tool out of that cork stop, shut it off, and then you would attach it looks like polyethylene service tubing that goes on to the house. Or in this case, it looks like a little larger, probably a commercial building.
Yeah, so thank you for that, Steve. Now we're going to cut to a little more detailed conversation of that with a live presentation by Alan in our studio, where he's going to talk through best practice connections to the main. Alan, take it away.
Hey there, can everybody hear me all right out there? Perfect. So we have a great service display for you here. What we do, trying to accomplish here is like what we would do in a road show, where we bring 10,000 pounds worth of gear to wherever your location is, and then you can touch and feel it and see all the parts and pieces. So we did a myriad of different ways to connect to the main, including on this side a flange adapter that would connect to some of those valves or change in material types, and an MJ on the other side. So this is a self-tapping electrofused saddle. So the electrofusion saddle here, the bottom part of it only straps on while we're fusing it, but you'd fuse this directly onto the HDPE. And now this is one of those that I was talking about, this live tapping. If you can see this, you could see the cross section for us of the cutter that goes through. And as we operate this, that cutter will go down and cut to the outside of the high density polyethylene and hold that coupon for us back in through this apparatus. So Bob will be doing a demo in a bit on actual tapping in the apparatus that we use to do that. So the important thing is that this main stays live and you don't put people out of water through that process. So that's the uniqueness of this particular fitting. Now, if we look right here, we can see those threaded connections I was talking about. And this is another electrofusion fitting put right on the side of the pipe. And then depend upon, your preference of the taper and your cork stop, it'll go right into this connection. So this is threaded. The fitting is manufactured in a manufacturing facility that uses HDPE and does this particular fitting and builds that for that purpose. I'm sorry? Yep, electrofusion, excuse me. So here, this is a flex restraint that we would fuse to the outside of the pipe and then embed that area with concrete in order to be able to give us that anchor or thrust restraint as we need through it as well. So if we look at this fitting now, this is a electrofusion coupler. They manufacture these up to 64 inches in size. So that's pretty big pipe as we go through it. And here you'll see that we peeled this area to be able to prep this particular pipe for electrofusion. Now, when we get down to that virgin resin material, all fusions, whether or not it's extrusion, electrofusion, butt fusion, are all getting to that virgin resin material, and we're making a good solid polyethylene joint out of that as well. So here, this is another fitting, service connection, just with a larger pipe there, and you would fuse right onto this service connection as we continue through this. And here you can see just another mechanical fitting with a threaded connection here to be able to allow you to use mechanical fitting and make your service connection as we're looking there. Now, if we look at the very far end here, this is that belt and suspenders of the MJ adapter, and it is fused right onto the HDPE pipe. And then you bolt that directly up to the valve that you need as well. So, come right back over here. Bob left me a good gift right behind me. This is the Georg Fischer multi-joint. So this is simply another mechanism to be able to come through and couple. This would replace the electrofusion coupler in this manner. You could see these teeth that are right in there that are going to grab onto that HDPE pipe and hold that pipe for you as well. So this is another stout mechanical fitting in order to be able to do what you need to. So here, I'm going to show you that live tap that we're really interested in. Bob's going to perform it for us. Got another fitting that we're put together over here, and this is an electrofused saddle. And so what he's demonstrated is we are going to open up this corp stop to allow that tool cutter to come in and then get access to this existing pipe that's under live flow conditions. So we want to be able to cut that tap, the coupon, out of the exterior of the pipe, and then withdraw that tool back up so it holds the coupon as we go through. So within this tool and apparatus happens to be this particular cutting blade that will allow us to tap those types of material. HDPE has its specific cutting blade. If you're tapping ductile or PVC, to have a different type of cutter through there. And then now once that coupon is back out, Bob will shut the corp stuff off so that we don't have flow coming out of the corporation stop. He'll withdraw the tool, and then we'll be able to see the coupon within the cutting blade here. Bob just made this coupon, and you could see right there. All right, Bob, you did great. You're hired.
Well, thank you, Alan.
Okay, so lots of different ways to be able to make all this happen for you. And we just brought you a few of the options here right from studio. Pete?
Thank you, Alan and Bob. Great job. As always, the live demos add a little spark to what it is we're doing. We've got 10 minutes before the top of the hour. This program will run until 15 minutes after the hour. And let's head back to Dan Landy, who is running the deck. We now have over 22 questions that have been answered. So guys, keep those questions coming at us. One of the questions we just got, Alan, was on the question of, is sidewall fusion still active in the municipal water market? And as I said in the response, yes, it is, but it's been pretty, here's an example of it, Alan, thank you. It's been taken over by electrofusion. The electrofusion couplers and saddles have become much more complex and much more prevalent and better products. And our understanding of how to teach electrofusion and make sure that the specifications cover it adequately has gotten better. So electrofusion has become, in Europe, Alan, it's even more common than butt fusion. So it just kind of depends where you are in the world on what is the most common. This sidewall video that I shot was shot up in Austin, Minnesota. They do a lot of sidewall fusion. And right now we're butt fusing the service connection to the outlet of that saddle. Alan, take it away.
Okay, we had a great question that we really want to bring our experts on. So Steve and Dave, if you want to come and on video, we can have a direct answer to this question. Do you have to be cognizant of where you place your tap service connection, i.e. a certain distance away from a fuse joint on an HDPE main?
You know, we kind of recommend if you're 3 diameters away from the fusion bead, you know, the evidence of where the joint was, you're more than safe there. I mean, that bead or that joint, once it's been butt fused, joint is going to be stronger than the pipe. But that's just a rule of thumb that we stick with a lot of cities.
Okay. It's also important to note that for the presence of a HDPE fitting, our allowable bending radius comes to 100 tons that OD of the pipe, as opposed to in just regular pipe, it'd be 25, depending upon the DR ratio of that pipe as well. So good, we're going to keep going through it, and we'll get to some other information pretty quickly, including pressure testing. So what are we looking at here for guides for electrofusion? Steve, got the MAB-01 and MAB-02, and they'll tell us, give us really good guides as to how to properly do electrofusion, correct?
Correct. Yeah, so the material or municipal advisory board came up with these procedures for electrofusion because in the past it was manufacturer by manufacturer. Each one had their own kind of small tweaks or different procedures. So the municipal advisory board, which was a bunch of municipalities that had quite a bit of experience with HDPE. One of them in my area that contributed to this is Fort Wayne, Indiana, which is a big advocate for HDPE and uses it in the majority of their replacement program and expansion program in their water system. They came up with these procedures, so there's kind of it's nice to have a generic procedure that's not manufacturer specific, but it's the standard steps of cutting a square pipe end, making sure it's clean, and then marking the pipe. So the reason for marking the pipe is that you want to ensure that when you're peeling, and we used to call it scraping, but now the new buzzword is peeling, because we're actually peeling a layer of material off of the pipe because we want to get rid of any oxidative evidence. So because when the pipe sits out in the sunlight, it oxidates. So it's essentially we got to get rid of that contamination. Just a small layer, but you get rid of that. So it's pure polyethylene in the fusion zone. And so when the coupling, in this case, melts the inside of the coupling, when the wires heat up that are built into the coupling, the wires heat up and they melt the inside of the coupling and the outside of the pipe, and pressure builds because everything that heats up expands. And so when the material tries to expand, because that coupling is fit tight to the outer wall of the pipe, that the material cannot escape, it kind of dams up, similar to, imagine a volcano in Hawaii. You know how the lava kind of pours and slows down and kind of creates that leading edge, and it stops and it dams up. And so that's how the pressure builds, and then the material inside the coupling and outside the pipe mix together during the heating process. And then once that's over, as it cools, it creates a joint that's stronger than the pipe itself. And the MAB kind of made those standards that were all manufacturer based, that made them kind of generic, so we can all refer to them as the standard in our industry.
So I'd just like to reinforce that when we get to virgin resin material, so this process and procedure peels that oxidized layer away, which is what Steve said, all of the fusion process is the same. So it's electrofusion, butt fusion, extrusion. They're all removing that potentially oxidized material and then just properly prepping it that way. So these fittings that we've shown, they are manufactured with those wires within the actual fitting itself and moves from that hot zone to the cool zone, as Steve had discussed. So that's just another example here for you to be able to see it. We're going to move pretty quickly in some of these. Here is a video for us on how to prep that external surface as well.
Hi, so I have the new Plasson U peeler. This is a size-specific electrofusion peeler or scraper. You'll see the cutting blade is right here, and it's set up on a spring so that as I push on it, it will automatically adjust to slight imperfections in the pipe if it's a little bit oval or out of round. And it does a really nice job of getting you a good even peel to prepare your pipe for electrofusion. There we go. All right, so I'm going to show you how this works.
And here we see just on the left of a larger pipe application as they're moving that around, prepping in the actual excavation itself. So yes, these tools are intended to be able to be put into excavations for you to be able to properly prep that surface as well.
Welcome, Corey Langston, to the floor.
Oops, here we go. Here's some more examples of the fittings that we have. And the one that you see on the left here has a electrofusion coupler right off of the self-tapping T as well. So we've seen quite a bit of these as we're moving forward. Here is another example of electrofusion tapping, simply a different style of fitting and a different style of a tapping device to be able to provide that connection through what we have here. So here is another example of that electrofusion process. So there are lots of tools available. Rusty and all of his guys have these available for you for rental to teach how to do that, or for you to buy it and do it yourself as well once we get through that whole process and properly do the electrofusion as we're seeing here. Rusty, you want to come on and tell us a little bit about some of the offerings and how one might be able to contact you and figure out how to rent the equipment that way?
You bet. Yeah. Again, our website is coreandmain.com, but you can contact me, rusty.reeves at coreandmain, spelled out.com, and I can direct you to the correct one, the correct region that you would be in. But we really, again, we offer fusion machines for rent. We also have them for sale, stocked new or used. Try to accommodate you whichever way you would care for. Long-term rental, we could even look at maybe providing credit back or something like that if you decide to purchase the machine. We also have the same thing for all of our electrofusion boxes as well. Definitely want to try to kind of zero in on what brand you prefer and that type of thing. And then, but the boxes really work on any coupler. With the couplers, it's not just the connections. Again, like we've talked about, electrofusion service connections, as well as L's, T's, or anything like that for electrofusion. It is pretty good for the smaller diameters for sure, or dropping down into the trenches. We do talk about a lot of trenchless applications. We have in-trench fusion machines that can do tie-ins as well, all the way up to 63-inch, and can drop in and do tie-ins. So again, happy to work with you however you would like. So you can also get on our website, and we have a fusible segment that will direct you towards our different regions as well. So however we can accommodate you, we'd like to work with you.
Okay, great. We'll have a contact slide near the end of the presentation as well. So the HDPE pipe does not convey electrical signal. So you do have to use tracer wire or RFID balls to be able to locate that pipeline in the future. So here we've got a couple of examples that RFID ball will send a signal to the surface to say that, hey, this is this asset and facility here in this location. So again, lots of different ways to do it. Here's HDPE for any preferred option. We used to haul this all around and set up the pipe display, which would take a long time as well, and to be able to show just the myriad of different options for replacing or using HDPE. Here's some fittings and cross sections that we've shown. And here, Pete loves to get these types of videos going. Pete, you want to come on and tell us what's going on here, what we're looking at? This.
Sure, we got this one from our friends at Strongbridge. So this, we're lifting up a lift truck in the air with all the weight on a Tega coupler. So a chain is not a best practice, obviously, to pick up something heavy, but at the top of that piece of pipe is a saddle that has been electrofused onto that piece of pipe. And that pipe is going to fail, Alan, before that electrofusion saddle does. Great example, kind of fun to do something like that. It's not scientific, but it certainly demonstrates the strength of a properly prepared electrofusion saddle.
Awesome. Okay, so I feel like we're really getting to complete show here that there are just so many different options for you for your service connections. As we've seen it, HDPE does work with the compression fitting. Now, these compression fittings are often not rated more than 150 PSI through that, but here you'll just put it right on the HDPE pipe in whichever mechanism you want to use that way as well. So pressure testing is our very next presentation here. And Dave, you want to tell us a little bit about how we would pressure test the pipe? I'm looking at ASTM standards here to be able to provide that guidance, F2164, and you've done a great pressure test for us and walked us through in other applications, so feel free to take it away here.
Well, thank you. A little bit of a passion of mine is to help engineers understand how to pressure test this pipe. And again, if you look at the designation there, it's the leak testing of polyethylene using hydrostatic pressure. As Richard will tell you, that the pipe is pressure tested at the factory, right? When they do a quick burst test, and it typically pass won't be more than 3.2 times its pressure rating. So 200 PSI pipe would be over 650 PSI before it actually bursts in pressure. Once we get out in the field, though, we want to make sure that there are no leaks, either at the fusion joints or at the connections to the other components of the system. So important here to set your test pressure at something that's reasonable. You don't want a test pressure that's any higher than the lowest rated component of your system. So even though you might have a 200 PSI pipe that could test at a 1.5 times at a 300 PSI, it might not be a good call to put your valves and your hydrants against that kind of pressure. So typically, a 90 PSI test, we are going to go 90 PSI service system. We're going to test at 135 PSI. We do have a little different process because polyethylene pipe expands and contracts using due to heat, thermal changes, and pressure changes. We do need to allow to prepare the pipe. And when we fill the pipe, we fill it slowly, never more quickly than we can vent it. We don't want any air trapped inside. We're going to do it, let the temperature between the pipe and the testing liquid equalize. And then we're going to pressurize it, get it up to its test pressure. We're going to notice that then, even when we can see no visible leaks in the system, that pressure will drop. And that's because the pipe is reacting to thermal and pressure changes. So we'll watch it drop, we'll add makeup water, watch it drop, and that can take as much as 4 hours. Typically, I'm finding about 1.5 hours. So unlike ductile and PVC that go right up to pressure and just stay there, this pipe is expanding, it's reacting to those changes. And once we reach that or become static at the just above the test pressure, we'll go ahead, and at that point we're typical to any other kind of pipe test. We're going to reduce the pressure test by 10 PSI, hold that for 1 hour, and a passing grade would be anything less than a 5% drop in pressure. We do want to depressurize slowly. We don't want to create water hammer in the pipe. And if we have any retesting that does need to happen, say we've got a leak in a valve or something like that, then we will let the pipe relax for at least 8 hours and begin our test. We typically prep for these tests in the afternoon, let the medium sit in the pipe overnight, and test first thing in the morning when the pipe is coolest.
Yeah, absolutely. So that expansion that you're talking about happens to be Poisson's effect as we go through. So that pipe, as it's pressurized, it expands and then comes through and just slightly expands that pipe because that material has to go somewhere. And that's that Poisson's effect in addition to the thermal effects. So a thermal effect would be that pipe underneath the hot sun as we keep going, and then that expansion would go as well. But part of the pressure testing is we would actively look for leaks, and then that's something that would be obviously seen in that process too. So Dave, you want to tell us a little bit about what we're working with here while the video is running?
Yeah, what I've done is I've connected a data logger, which is the same machine that we use to record the times and pressures used in a fusion joint. And I've connected that to a pressure sending port on the sample that I've created here. It's a 6-inch pipe with MJs on both ends. There will be a cap with a testing port put on each end. And we'll go ahead and fill this up until we get to our test pressure. You'll notice that we do want to be able to vent air out of one side. On the left-hand side, there is a vent. So as we fill, we can vent the air out. Any trapped air, of course, will cause us to have variations in pressure because we can pressurize air. We can compress air, but we can't compress water. So they act very differently to pressure. And any trapped air is also potentially very dangerous in the system. So we want to make sure we're completely vented. And that's the vent right there.
Well, in this particular example we did use Bob's live tapping tool to be able to come through and tap this fitting in that manner. And we were able to keep that pipe under pressure and underwater through that process. Pretty cool stuff here. Let me advance as well here. So here we're looking at the end cap in a little better detail, and then purging of all of that air. We'd see that by all the water now flowing out of that pipe instead of air through that. We want to make sure those end caps are very much secured through that process, and not coming off from whatever pressure we have within that pipeline. So a lot of good tips here on how to do a good, safe pressure test as we pump through. And yep, Pete, you got something for us?
So Alan, one of the key differences between pressure testing polyethylene and other materials is we're doing this above grade, right? Well, what are some of the things compared to other materials you're doing it below grade? What are some of the things when you do a pressure test like this that you got to be careful of with above grade testing?
So that thermal expansion and Poisson's effect as the expansion can sometimes have the appearance of makeup water added to this pipe as it's pressure testing. And then also we want to make sure that those end caps are secured on that pipeline as well. So you'll be filling it. We'll be making sure that it's done safely as it moves through. And that is definitely a unique aspect of polyethylene versus other pipe materials as it's installed. So here, we'll keep moving. Dave, you got something else to add?
We are using a hydrostatic pump there, which controls the maximum output from that. So we've got water going in, but only a certain pressure could leave. So it prevents us from over pressurizing that pipe and creating any sort of dangerous situation due to over pressurization.
Oop, yep. So let me move to the next one. It was important to note what Dave had talked about with the differences between a design rated pressure of the pipeline and then the operating pressure that we're going to be testing too. So here's just a little bit more support on that topic itself. That was definitely a good topic of conversation. But what are we looking at here, Dave?
Here we got a few different segments of the test. We've got the top right, we've got we're showing that venting as well. On using the mechanical joint on the upper right hand, upper left hand shows that hydrostatic pump, and there it's connected to the cap that would actually go on the right hand side of that sample right there. So that is an MJ. It's fully restrained. Would we want to use a flange there? No, flange is not fully restrained. An MJ, is it fully restrained? No. So you make sure that your testing cap is fully restrained as you put this under pressure. And then on the bottom right, you just see that we can scale this out to whatever we need. We just have to make sure that we have a water source that's compatible with the fill rate that we need to fill whatever length of pipe. So we've done everything from short 30-foot lengths. A typical is going to be a 300-foot length that's used on a pipe burst. But then we'll also do 1,200-foot 30-inch pipes that have to be filled all at once before they are pulled, or even after they're pulled underneath the river, for example, using high directional drilling.
So, yep, Dave hit on a really good point there. And as that pipe gets bigger, the logistics of being able to install it, pressure test it, all get bigger as well. So you'll definitely need to have a good solid water source when we're getting into much larger pipe to be able to provide what we need. So here's just the general process itself as we're finishing up with this test and purging all the air from the pipe. That's a good indication for us. A lot of times in the field, two workers can fuse up 500-600 feet in a long run, many times over during the week, and then conduct all these pressure tests at that same time as well to be very, very productive. So here's just another video of that pressure test monitoring through the McElroy data loggers we're going through and looking at it. So it does tap right there and gives you that pressure as we're coming through, and just still more information for you here, showing exactly how to do all this stuff with the tools that Rusty and their crew really have through there. So at the same time that you're doing some of these pressure tests, we can chlorinate that water and provide disinfection or proof of disinfection. So that process sometimes is called the pre-chlorinated pipe method, as to which we're making sure that the interior of that pipe is fully disinfected. And this gentleman I've got on screen here is from the Tulsa Department of Health, and we were both very happy and pleased that this pipe was in fact disinfected. Aaron Davey was taking the sample with us, and then once we drain that pipe, we do have to dechlorinate that pipe and any of the water coming out of that pipe through it. We use a sample of dechlorination tabs, and then that'll do what we need to. So I'm going to ask for everybody to come on and we'll talk through some of the resources, some of the other information that we may have. I'll navigate through these slides themselves while we're having any closing comments. Pete, you got something for us?
Yeah, I just want to say thanks to everybody for participating, Alan, as you page through our resources that are available, many resources that the industry has available. But importantly, if you have a project that you want help with, the Alliance for PE Pipe does not charge. We have 3 engineers. It's what we do. We help people use poly better. And that process is pretty easy. You just send an email to one of these people. We're on the lower left, and then the guys from WL and Core and Main are in the upper left. So give us a shout. We'll help you with your project.
I'd say too, Peter, a big part of that is kind of that value engineering for maybe somebody who has not really used polyethylene before. It does really go in a little bit different. It's more of an engineered type product, and there can be some cost savings with that. So I think that's very key to kind of get another recommendation or another eyes looking at it. So happy to do that.
And Alan, could you come on and tell us, how do we get our CEUs, our PDHs, our CEs for spending an hour and 15 minutes with us today?
Great. There'll be a survey at the end of the webinar. Once we close it out, then you'll want to make sure that you fill in that survey with the state that you're in, the requirements of PDHs or CEUs, and that'll be the quickest way to be able to make sure we make connection and get you the continuing education credit that you need. So the survey, stick around for us afterwards, and we'll ask you a couple other questions as well.
Alan, good comment from Jason LeMay, our good friend in Lincoln, Nebraska, mentioning the importance of timing of that above grade pressure test. He recommends early morning.
Exactly.
That way that hot sun isn't beating down on it too much, and making sure that you expand that pipe as we go through. So love to see our fans of the Alliance for PE Pipes webinar materials coming on and helping make sure that we reinforce all of these good points for you. So this was a service connection webinar is what we've got, with lots of other connections to the main line. And then the next in our series in October happens to be underground installation of HDPE pipe with thrust restraint. So we'll bring on Brian Dorward, a fantastic 35-year trenchless engineer as well, to talk about all the thrust restraint options available to the HDPE industry, as well as talk about underground installation of HDPE pipe itself.
I
Wonderful.
think there were a
Great.
couple of questions about
Yeah.
the thrust anchors as well. So that'll be a great one for a lot of the people that were on this.
Yeah, Rusty, we get a lot of questions on that topic. All right, with that, let's close it out so people can fill out their form to get their CEUs. Alan, great job today. Alan, Robin Cruz, thanks again for having us on. And Rusty Reeves, Steve Breedemeyer, and David Mosier from Core and Main. Great job today, guys. And thank you for helping us put this deck together. And also a quick shout out to our friend, Richard Kalasa. And guys, on the bench, over 40 questions answered. Great job today. And with that, we'll sign off. Please fill out that form. We'd love to send you a CEU. And with that, so long and see you next time.
All right.
Thanks, Peter. Thanks, everybody, for joining.
Bye now.